Hello everybody, welcome back to another video. Today I will be giving you a brief overview on object-oriented programming in Python, EP1. So object-oriented programming is basically classes and objects. It's going to get a little bit more complicated than that, but that's just overall. So I already know I taught it in the past, but this is more simple and it's easier to understand because I am using Pokemon and it's going to be just a short lesson. It's not too long, but it has a lot of detail in it. So let's look at our first code. By the way, the link to download this notebook is in the description if you want to try it out for yourself, or you can do it along with me. You can download it and then open it in Google Colab or in Jupyter Notebook. So how to create a class. The first thing you want to do is you want to put class, right? Type out like the word class and then the name of the class at the behind of it, which is Pokemon in my case. And then after that, you have a little, how you call it, colon, and click enter, and it should give you a little indent over here. And in that indent, you can put the attributes of the Pokemon or whatever you want to create, like name, and then the string of the name, and then attack and the integer. And once you did that, after that, you have P1. P1 is Pokemon 1. It's just a variable, and it equals to the class Pokemon. So P1 equals to class Pokemon, and print P1.name, which is Pikachu, and comma P1.attack, which is 20. And it might look a little complicated, but let me say something. So the class right here is like a blueprint where you can use it over and over again to create different stuff. So pretend like the word car is very general. So there's like could be Toyota, Ford, Chevrolet, whatever, but basically the car is kind of like the class, and then P1 is kind of like the model of the car, like Chevrolet, Ford, Toyota, whatever. P1 is kind of like the model and the class is the car. So it's just an overall thing, like Pokemon and Pokemon 1 is a comparison. We can implement this is that we can put this inside of a big string. So print P1.name, which is Pikachu. Pikachu has an attack power of, and then str P1.attack. This is so that I can combine it with a exclamation point, but you don't need this str if you don't want an exclamation point at the end. But since I do, I just put it there so it's the same type as each other. So of str P1.attack, which is 20, and plus exclamation point. There we go. Pikachu has an attack power of 20, and that is a way to implement classes into your code. Let's look at another one called Python Constructors. Not like Python oh, that's actually really ironic. Can get a constructor snake like this. It's a snake, and then there's the Python like this. Oh, Python principles, no. But there's the boa constrictor or constructor. Like some people might read it as constructor, but Python constructors, it's very ironic, but let's move on. So Python constructors are such as dot underscore underscore new underscore underscore. That is a little Python constructor that we can use. So class Pokemon defined underscore underscore new underscore underscore self. This Python constructor is used to every time a new object is declared, like P1 equals to Pokemon, like this is how to declare an object. This underscore underscore new underscore underscore constructor gets activated, and to check that it actually gets activated, we're going to do define new self print Pokemon has been created, and then if it's been defined, right, it will trigger this constructor and it'll print out this thing. So let's try and run it. As you can see, it did trigger it, so it printed it out, sorry. And if we were to trigger it again by using P2, it should print out 2 times. There we go. So even how much objects it is created, there is always going to trigger that underscore underscore new underscore underscore. It's kind of hard to say, but you'll get used to it. And yeah, that is Python constructors. Let's move on to initializing objects. Initializing objects is using it with the underscore underscore init underscore underscore method. So we have a class called Pokeball, and I'm sure most of you know that there is different types of Pokeballs, like the normal one. There is the Ultra Ball, Great Ball, and Master Ball. I am doing some of them in Pokemon Go because I don't know every single one, because there's like Safari Balls and a lot more in different game modes. But I'm only gonna do it for Pokemon Go, and I'm pretty sure does Pokemon Go have a Master Ball? Does Pokemon Go have a Master Ball? Oh yes, you can. You can. Oh wait, really? Have one missing game so far? Oh no, there is no Master Ball. So there's no Master Ball in Pokemon Go, but I just added it there because it's very infamous. And it's because it has 100% catch rate. But anyways, let's get back to the code. So we have our class called Pokeball, and inside of that we have a method or a constructor called init, and init is used to create objects. Like kind of like the new one, except that this is actually used to create some. So define init self, name, and C rate. These are some parameters or not global variables. I mean local variables that is stored inside of this function right here. This is also known as a function. But anyways, these are some variables that we can use later on. And inside of that, we have self.name equals to name, and self.catch rate equals to catch rate. So self, name, and catch rate. And let's look at this one. So now we're declaring 4 objects. Okay, we have PK1, Pokeball 1, Pokeball 2, Pokeball 3, and 4. So Pokeball 1 equals this is the name, by the way. Name is Pokeball, comma, catch rate, as you can see here. Name, comma, catch rate, 50%. PK2 Pokeball, by the way, is the name of the class, so that's not actually the name of the actual PK2. And PK2 equals to Great Ball and 65%, so it has a Great Ball. It's called a Great Ball and has 65% catch rate. By the way, these catch rate are not accurate because I just made them up. But they have a ranking by themselves, so I just assumed I took an educated guess. But yeah, the Great Ball has 65% catch rate. PK3 is an Ultra Ball with an 85% catch rate, and PK4 is a Master Ball with a 100% catch rate. So now we can use this and we can print some things out, like PK1.name has a catch rate of, and then PK1.catch rate. And this basically makes it so that we can like print out stuff that is actually meaningful instead of just Pokeball 50%, but it makes it more context, I guess. So Pokeball has a catch rate of 50%. You can change the Pokeball or the Pokeball's name and the Pokeball's catch rate by changing the 1 to 4 over here. So let's do the Master Ball. So instead of 1, it's 4, PK4. There you go. Master Ball has a catch rate of 100%. So there is how to implement it. Let's look at the next one, which is adding attributes to empty class. So right now we have an empty class, and the way to create it is to just do class and the name of the class, which is Pokedex, and colon after that, put in the command pass, which will just make it so that there is no errors that's going to happen. It just declares it as an empty class. Once we did that, we can do pdx, which is Pokedex equals to Pokedex. This is just declaring a object, so don't get surprised. It might sound a little complicated, but after that we will do print pdx.name underscore pdx.cp, which is two attributes we're going to be adding to our class. However, it's not there yet, right? So what happens when we run it? Of course, it's going to come up an error because there is no attribute name and cp in there yet. So once we activate it by using these commands, pdx1.name equals to Caterpie and pdx1.cp equals to 25, it should have it. And there we go. Once you type it out again, there is no error. Instead, it types out Caterpie 25. So there is how to add attributes to an empty class. You can even do this with a class that already has some attributes to it, and you can add even more to it. It works both ways. Let's look at some object methods. So we might have already known underscore underscore init underscore underscore, but we can also create our own method called PokeDetail, and I'll show you what it does. So we have a class called createPoke, and we can create our own Pokemon, and we can define underscore underscore init underscore underscore as self, name, and CP, and P type. Self is of course mandatory. We need to have that in order to declare our Pokemon's name and stuff. But self, the name of the Pokemon, the combat power of the Pokemon, and the type. The reason I didn't put the straight type like this is because it's a Python keyword, and I am scared that's going to have an error, so I just played it safe and named it p-type for Pokemon type. And after that, we do self.name equals to name, self.cp equals to cp, self.ptype equals to ptype, and so on if you have more. But after that, we will declare another function or method called poke_detail. And inside of there, we have the only one parameter called self, which is mandatory, as I said earlier. And well, it's not mandatory. It's mandatory if you want to do like adding in or changing the name of it, like what we did up here with the Pokeballs. And once we did that, we're going to declare three print codes. Print the name of the Pokemon is, and then the self.name, which is what we're gonna set. Print self.name has CP of self.cp. This is so that we can use a Pokemon's name instead of just writing your Pokemon. And we can do print the type of Pokemon's name is self-type, which self-p-type, which is the Pokemon's type. So once we did that, we need to declare the actual name, the CP, and the type. So I will do p1 equals to create Poke, which is the name of the class, Python, which is my name of the Pokemon, and 100, which is the combat power, and grass, which is the type. After that, we just need to do p1.pokedetail, which will call this function or this method, and it will just do the rest for us. So as you can see, if you run it, it will come up. The name of the Pokemon is Python. Python has CP of 100, and the type of Python is grass. And yeah, you can create your own Pokemon like using classes and object-oriented programming. Of course, there is going to be more episodes later on, so I hope you stay tuned for that. And again, see you in the next video. Bye!